Good morning to all, Professor here. Today we'll see Unit 3, back topic. In fact, Unit 3, first topic is learning the weights of a linear neuron. First, we should understand the perceptron concept. So, already you know what is perceptron, what is single layer perceptron, and you have a basic idea about multi-layer perceptron. So, what's the perceptron conversion procedure? Yes, it works by ensuring that every time the weight changes, they get closer to the feasible set of weights. But this is this can guarantee that the accuracy in single layer perceptron. This cannot be extended to a more complex network like a multi-layer neural networks. That's why the multi-layer neural network do not use the perceptron learning procedure because the average of two good solution may be a bad solution in multi-layer perceptron. Now, what are the different ways to show that a learning procedure makes progress? So we can, instead of showing the weight, get closer to a good set of weights, we can show that actual output value get closer to the targeted value. That is our ultimate aim. This can be true for non-convex problem. So we can go for averaging the two good set of weights may give you a bad set of weights, but it is not true for the perceptron learning procedure. So always for a simple example, the linear neuron with a squared error measure, we can use. Then we can understand linear neuron. The linear neuron has a real valued output, which is weighted sum of all the inputs. The aim of learning is to minimize the error. Ultimate aim is to minimize the error. You know the output of the linear neuron, y equal to summation of I equal to 1 to n, xi and wi. We can solve it using two way, scientific solution and engineering solution. The best solution, ultimate aim is to bring the exact output by changing either by changing the output or changing the input values, adjusting the weights. Our ultimate aim is to bring the desired output. The scientific answer, we want a method that real neuron could use. What is the engineering answer? We want a method that can be generalized to a multi-layer non-linear neural network. The analytic solution relies on it being linear and having a squared error measure. Iterative method are usually less efficient. Let us take the toy example. Each day you are consuming lunch at your cafeteria. Your diet consists of fish, chips, and ketchup. With several portions of fish, ketchup, and chips, you are daily consuming the meal, and then you are paying the price. The cashier tells one price, total price of a meal. Every day you are paying. Then this is what the iterative approach to analyze the price of each portion of item you are consuming. So start with random guesses, and day to day you can adjust the weight, and then you can calculate the price. One day you can ultimately understand at what portion of item you are paying what amount. This is what the toy example. Now solve this meal with the different items. First take the price calculation. X portion of X portion of fish and Y portion of fish. Here X of fish, W of fish, then X of chips into W of chip, X of ketchup, W of ketchup. So these are the calculated price of the entire meal. The input, what is the input, and then what is the weight of each portion is given. Then we are calculating the meal price. Already you know the portion is nothing but weight. weight of fish, weight of chips, and weight of ketchup daily you're consuming. Starts with the initial guesses. So initially, this is the true weight of the entire meal. So the price of the meal is 850 because daily you're consuming 150 piece of fish because two portion of fish and five portion of chips. Each portion price is 50 and three portion of ketchup. Each portion price is 100. Total is 850 you are paying. Initially, you have assumption each portion is 50 rupees. Then you are calculating the price meal price. Then two portion 50 rupees. Then five portion 50 rupees. Then three portion each 50 rupees. Then the entire price of meal is 500. But the actual weight, what is the actual price of a meal? 850 goes. Now your calculation is giving 500. Then what is the residual error? 850 minus 500 is 350. So this is what the error we are getting. Error already you know. Error is nothing but the difference between the actual output and the current output. Current output is 500. That already the targeted output is 850. Then we are differentiating both the things. You are getting residual error 350. So this 350 again next day while you are calculating the mean price, you are adjusting the weight with the help of delta rule. So here the delta rule comes. So delta Wi is nothing but changes in weight. Okay, you can uh, fix the price for each portion differently. Now take the delta Wi equal to epsilon of xi into t minus y. With a learning rate of epsilon 1 by 35, the weight can changes plus 20, plus 50, plus 30. If you are taking the epsilon rate as 1 by 35, the changes in weight is plus 20, plus 50, plus 30. This gives the new weight a 70, 100, 80. 70 portion of fish, 100 portion of chips, and 80 portion of ketchup. Notice that the chips weight goes worse. So like this, you can recalculate the uh, weight, recalculate the weight with the help of new learning rate. So the learning rate now we are having 1 by 35. You can reduce it to 1 by 25, 1 by 10 like that. If you can calculate the weight of the portion and then you calculate the amount. Then one day you will get the exact price. Yes. See here, this is the derivation of delta rule. What the delta rule says? Yeah, in delta rule, we are identifying the error rate and based on the error rate, we are adjusting the weight. Okay. So this is what deriving delta rule. Now, differentiate the error. First, what's the error? E equal to 1 by 2 summation of t power n minus y power n whole square. After differentiating the error, dou E by Wi, dou Wi. So differentiating error with respect to weight, which is equal to 1 by 2 summation of dou y power n divided by dou Wi. Then differentiation of e power n divided by differentiation of y power n. So finally you will get minus summation of xi power n t power n minus y whole power n. So this is what the final error we are getting, differentiation of error. Now weight changes Wi, del Wi which is equal to epsilon. Already you know minus epsilon of dou E by dou Wi. Dou E by dou Wi, now you find the equation. Apply the equation here. Already minus is there. One again, one minus. It will give a positive value. Then summation of epsilon of xi power n into t power n, targeted output minus exact output, y power n. Current output. So this is what the delta rule. So in this way, you can apply the delta rule. You can change the weight of a portion. Then you can recalculate the weight and you can adjust the price. Then you can calculate the exact amount what you pay for each portion. Okay, that's all of the today's class. Now we'll recall the things what we learned today. So first, learning the weights of linear neuron. Then we understood why the perceptron learning procedure cannot be generalized to a hidden layers. because perceptron learning procedure only applicable to the single layer perceptron. It is not applicable to the multi-layer perceptron. Yes. So, and we have a different ways to show the learning procedure. How the learning procedure makes progress. There are two methods. One is a iterative procedure and one is a linear way. So the linear neuron, the output of the linear neuron is calculated with the help of weighted sum and its input. This is what the output of the linear neuron. Then we can solve this uh, with the help of two methods, scientific answer and engineering answer. Obviously, engineering answer are having two solution, analytic solution, iterative solution. We can see iterative method. Example, each day you are consuming lunch at cafeteria, then you are paying some amount, then now you are calculating the amount that will be given and weights of each portion. Then the exact price you are paying is 850 per day for a different type of different portion, different items. Then you are assuming uh, you are paying 50 rupees per portion for all the items you are consuming. Then you are calculating meal price is 500. Then the residual error is the original price is 850. You are paying 500 means the residual error 350. You have to adjust this 350 rupees to all the items. So you have to apply the delta rule. Then check the del WI, that is weight changes. So based on this delta rule, you are again calculating the meal price. It comes around 700 means again you are apply delta rule. Again you recalculate the amount. Finally, you get the exact amount 850 and you know at what portion, what amount you are paying daily. So this is what the learning the weights of the linear neuron. Okay, thank you. Thank you, Anurag. Thank you. We'll see in the next.